Hi everyone, my name is Dithi and I'm one of the directors of Bishop Redding's STEM team.
Hi, my name is Murphy and I'm also one of Bishop Redding's STEM directors.
Hello, my name is Tam, one of the STEM team instructors and this event's project manager.
Today we will be sharing some insight for high school students who are interested in pursuing a STEM career.
Whether you've decided on your future career pathway or are still exploring some options, we hope that this event will be informative and will provide some guidance.
We have had the honor to meet with a number of very special guests, ranging from nurses to professors to engineers. We have had the chance to interview professionals from the science and engineering fields.
Today we are asking 6 different professionals from various science and engineering fields the questions that you, BR students, have sent to us. From work-life balance to post-secondary education to real-world, on-the-job experiences, we are uncovering the behind the scenes for several STEM careers. So let's get started.
Hello, I'm Murphy, and I'll be the host for Bishop Redding's STEM team interview with Marina Curak. Marina is a senior resource analyst at Liberty Power. We're super excited to have you here, Marina.
Thanks, it's great to be here.
So, starting off with the first question, is the engineering workload manageable, and are you able to have free time? Engineering degrees generally have a reputation for being really hardcore. So, can you talk a little bit about that?
Yeah, it's a good question. I love that this is the first one. Yeah, so they get that reputation, not misplaced, I would say. Uh, I did 4 years of undergrad and 2 years of master's, and it's definitely a huge workload. I would say the biggest shock to me, I did school in the GTA, in high school in the GTA, then coming from high school to university. The first year, first semester was the hardest transition. I think nothing was quite like learning how to study again, and managing your time, and really all the warnings that I got from other engineering students I kind of dismissed, like, oh yeah, I hear it all the time. No, really, it's really difficult, but you get used to it after a while, especially after first year or even first year or first semester. You start learning how to manage your time. You start understanding what the workload is, how to best work at it. Engineering is a team sport, so really leveraging those connections that you meet in classrooms, doing problem sets together, figuring why you didn't get one answer, they got another answer, and things like that. So it is tough. I'm not going to sugarcoat it. I think maybe in a semester I would have 1 or 2 full days off where I didn't study. But that was just my experience. That was my work ethic. And everyone sees it a bit differently, but it's definitely a lot.
Wow, 2 days off per semester. So that's definitely a demanding degree. We can tell just from that sentence. So strong work ethic and organization skills are definitely needed. Moving on to the next question. A lot of careers and fields of STEM have a lot of like underrepresentation for females in many like minority groups. So what has been your experience with being in the engineering field? How has that been as a woman?
Yeah, another excellent question. So I'm in mechanical engineering, which is one of the lowest percentages of female engineers, both in classes and in industry. I had single digit probably percentages or low above maybe 10% if we were lucky, very low representation. There's a couple things to take into that. What I took from it was the female engineers really do become quick friends really easily. We'll all just gather together and, there was that bond. But also, I find that most of the engineering students, regardless of their gender, everyone's in it together. At the time that you hit second year, like, nobody cares who you are, where you're from, or anything. You're all just trying to survive together. um, that doesn't mean to say that your comment comes from a question, from an area where there are some difficulties, and yeah, that does happen. That happened in my undergrad, that happened in my master's, where you get these comments maybe that weren't great or disrespectful, but I think it only motivated me even more. And being in the industry, there is a lot of less women here too, and a lot of less women that stick around to get their professional engineering designation. But for the most part, everyone's trained to be critical minded. Everyone's trained, show me how you get your answer using scientific principles, and they don't really care how you get like who you are. So for the most part, I would say it's like really supportive environment. You'll get those comments, but you'll get those comments, I feel like, everywhere you go. You just have to make sure that it doesn't let you get down, and you stick to the science, because at the end of the day, as engineers, that's all we care about.
Yeah, great insight. Thank you so much for that, motivation. I know so many females may be, discouraged because of that representation. They think it's not going to be a welcoming environment, and they think they don't want to be in that place of work because of the comments, or because of, being looked at as less. But I definitely think that, you need to really stick through it, like you said, and after all, it looks like it's a pretty welcoming community, and I think there will be situations where it isn't really the best, but you do have to stick through it. So thanks for that advice. Can you tell us something interesting or surprising about your work?
Um, I even forgot what I put down for this one. Interesting and surprising. So I work in the renewable space, just coming straight from graduate school, and you read a lot about renewables, and people are slowly transitioning. Some countries quicker than others. One of the more surprising things people may not know about renewables is how competitive it is. People always hear negatively, maybe negatively, about renewables, but when they find out it's more cost efficient than like coal production plants, then you were saying, oh wait, why are we sticking to these methods that are outdated, not good, and even from a cost standpoint, not as, doesn't even make sense. So I think that's one of the big surprises that people, when they go from a different energy space to the renewable energy space, find.
Yeah, I think that's definitely something that's not really like common or known. So that definitely like makes sense that it is quite surprising. So a lot of you know, definitely climate change is name, and I think with engineering, it's definitely one of the major fields that is experiencing a lot of change. So it's definitely a good career to be in and to have, and has a great future as we move into towards renewable energy. So as we said about being a woman in STEM and how representation is important. You are in a senior position, so that is amazing. Can you talk a little bit more about that? What's been the biggest challenge about being a leader, being in a senior position like that?
Yeah, it's a great question. So I've been managing a team of three, and this all happened during COVID, my promotion, where my boss left for a different opportunity early on. So we all had to make everything work on top of the pandemic. So being in a senior position, being a leader, you really have to take yourself away from a situation and say, the best way to manage me is to leave me be, give me my time frames, and I'll manage it. But you have to really respond and engage how other people manage their time. What's the best and most effective way to communicate with them, to motivate them, to make sure everyone's on the same page. So it's really learning more about people management skills, being in a senior position. And in my role especially, I'm an in-house engineer at my company. So I deal with a lot of non-technical people. When you get into those more senior positions, you have to then speak to the people who make the decisions about the money, and they're not going to understand the technical part. So it's knowing your audience. How are you going to communicate your technical jargon in a way that makes sense for people who don't have your background? Because that's one of the most important skills as an engineer, to be able to communicate.
Yeah, so we see the challenge mostly coming in from the communication and team dynamics type aspect, rather than, the engineering and the actual work that you do. So that's definitely something that we need to consider, as high school students when we're interested in engineering. There's so much skills to develop, so many great opportunities that we should take a part of that are not just about engineering itself, but, building these great skills to eventually be a leader in your field. So that's great, great advice and very eye-opening. So speaking of high school, when did you start gaining interest in mechanical engineering?
Yeah, it's a great question. So I wasn't at all thinking I would go into engineering up until May of grade 12. I applied to it, just one engineering program. Everything else I applied to was business. I thought, hey, like I did enjoy physics and chemistry, sure, like I'll go for it. But my purpose was always to go into a field where I was able to do sustainable energy, and I was trying to think of what's the best way forward for that. So when I applied to university, I applied only to the general engineering program at U of T. When I first started thinking about mechanical engineering in the most simplest terms is dealing with the physics of anything that moves. So that really encompasses a broad area of anything you can possibly work at afterwards. And so I started to really like my mechanical engineering courses in first year. And then we also had a seminar for each discipline to talk about the different types of fields you can go in and different types of specializations. And for mechanical especially, there was a specialization that I did, which is called energy and the environment. And I thought, hey, this is literally spelled in right here. I'm enjoying these courses. It seems to make the most sense for me.
Yeah, so you talk about going generally in. So what really sparked that, like why did you start gaining interest in mechanical engineering?
Yeah. So I was responding just to first the course because, as you take even these courses in high school, you're like, oh, I don't like that one. This one seems interesting to me. It helps you narrow down. You may have a passion for something, but how do you kind of support that passion and what is, your academic interest in that? So it was first from the courses, and then just talking to, what you folks are doing right now, talking to upper year students, talking to people who are doing the type of things that I'm now doing and how they get hit there. And then I'm like, oh yeah, that doesn't make sense.
Yeah, so speaking of courses, I think a lot of students my age, when they're applying to universities, they kind of go off of like reputation for many programs. So it's a really interesting point that you brought up about courses and how they really have built that solid foundation and or spark that interest for something because this is where you're actually going to be doing in a degree. So it's definitely something a lot of students should be like focusing on rather than reputation of a program or a reputation of a university, although they are important, but in the end, it is really the courses that do matter. So, great advice that we can pinpoint. So how did you know, like which field in engineering interested you the most? Like you talk about your interesting and passion for climate change. So how did that begin?
Oh, as long as I remember, I was always interested in climate change and sustainable energy, just how I was raised. And I'm sure Al Gore's The Inconvenient Truth also sparked a lot of attention when I was really impressionable and young. So I always just had that mindset that that's what I was going to be doing. And then I was merely in my later high school years just trying to figure out how to best support that. So I was lucky that I knew what my passion was from the start, but I know a lot of folks and a lot of my friends didn't at the time. And I think with STEM, but particularly with engineering, um, you don't need to know what exactly your end goal is. And that's the benefit of going into these more general first year programs or figuring it out. A lot of my friends aren't engineers yet they studied engineering because STEM and engineering, they teach you how to problem solve, they challenge you, make sure you know how to critically think. And if you don't know the way that you're gonna, work in the industry, that's okay. You guys are still so young. And a lot of people, even my age, are still figuring out what's the more end goal there. So I think I was lucky to know what that was, but that's okay if you don't.
Yeah, so it was more of a passion-driven type decision. So you knew the passion, just didn't know which degree, and then figured it out from there,
Yeah.
which is probably the best thing to quite do, honestly, because in the end, you want to do what you're passionate about, because this is where you'll be most successful. So great advice. So speaking of advice, what advice, if you were to give, you know, one thing or multiple things that are very important, what advice would you give to students who want to pursue a career in engineering?
Um, don't be so tied to your grades. I was so making sure I was on Dean's List all these years later on, and I thankfully was, but I remember just the transition for me was so rough in first semester of first year. Um, you know what? No one's going to care what your first year grades are, and a lot of the times they're not going to care how you do as a general thing. It teaches you a way to think, and grades are important, don't get me wrong. That's why everyone challenges in STEM to make sure they get the best of the best grades. But I would say don't get hung up on it. There are, you're there to learn, and there are different ways of learning and different ways of showing it. And it maybe for me, it took me first year to really get the hang of it, first year and first semester, and before my grades improved. So for an engineering student, I'd say don't cry, don't worry. It's gonna suck, but it'll be so worthwhile in the end. And even if you don't know, for those who don't know what they want to do, I would just recommend doing something that you're passionate about. Like you said, I don't regret any of my choices every day when I'm in the industry. I love what I do every single day, and I love bringing it to the table. I know I'm tackling an important problem, so whatever challenges you all think you need to handle or face or do, or know that you're the best person to fix it or try and fix or be part of the solution, you have time to figure it out, and that would be your most successful way forward.
Yeah, so in a nutshell, just follow your passion and don't focus so much on and nitpick at every small thing, but in the end, just try your best. So thank you for
Exactly.
that. Yeah, thank you so much for that. And moving on to our last question. So you said that you don't really regret anything, but would there be something that you would change about your professional journey? Like, would there something be that you would want to do different now looking back?
Um, I don't think so. Everything that I've been through, I'm a firm believer in everything happens for a reason, and you can't really look at and nitpick at every single thing what you would do differently. Oh, on this exam, if I just had my calculator radians or degrees, like you can focus on things like that. Um, but yeah, I don't think I would change anything differently. I've been really fortunate to work in a field that I've really been passionate about for so long. So I'm lucky to get here, and yeah.
Yeah, I think that just goes back to like your philosophy just goes back to um like stop nitpicking in every small thing because in the end it all works out. So thank you so much for that. I think that wraps up everything we have for you today. Thank you so much for your
Thank you.
time. You've had some awesome insight for our audience. Thank you for that.
Thanks so much.
Hello, my name is Aditi, and I'll be the host for Bishop Reading STEM Team's interview with Raj Pathak. And Raj is a solutions and software architect at Amazon Web Services, or AWS, in Seattle, Washington. So we're super excited to have you here, Raj.
Thanks a lot for having me, guys. Excited to have the conversation today.
All right, so to get started, could you describe a typical day in your life as a solutions and software architect at AWS?
Yeah, without a doubt. And I think the best way to describe what my day-to-day looks like is to kind of explain what AWS is. So think of AWS. We are the largest cloud company or the cloud provider on the planet. So I think of all the really popular websites you guys use today, like Amazon.com, Netflix, a lot of others, they all run on AWS. So they use our infrastructure, they use a lot of the services we provide. So a large part of my day is, helping customers that like Netflix, like Amazon, run their applications, their websites, and really their business on AWS. Working through technical challenges they may have, or thinking through, hey, I want to solve a new problem. How do I use technology to solve that problem? A bit of coding, a bit of kind of design on how we build the application, and how do we scale it to a global audience. So a lot of conversations more on the engineering and technical side of things.
Awesome. That sounds really interesting. So what do you like most about working in software?
So the reason why I like to say I love this job is it's a combination of not only the most emerging technology out there today, right? Like think artificial intelligence, think like things like your IoT, sensors, robotics, whatever it may be, but also working with our customers, right? They're solving some really cool challenges that affect our day-to-day, right? So getting to implement technology just to better not only my life, but the people around me is really cool. So that's what I like to say, is the most interesting part of my day.
Yeah, that sounds really, really great. You have the technical side and also how you're able to solve problems, help customers. It sounds really great, Raj.
Yeah.
So to recap, you've graduated from Western University, where you studied computer science, actuarial science, and applied mathematics. So how did you make the most out of your university experience in a computer science program at Western?
So I will tell you, there's two things. So one, if you do decide to pursue computer science in undergrad, whatever university you go to hackathons, right? I think hackathons are the single best place to go to when you're trying to get a good experience in computer science. I don't remember anything I learned in my classes, but I do remember going to hackathons. And the cool part is that they pay for your travel. So I got to go to places like Philadelphia or New York or Cambridge, and that was entirely paid for. And I got to do some really cool hacks, and I got to meet some really cool people that are out there in the industry today. I actually got my first job at these hackathons as well. So highly recommend, while you're an undergrad, go to hackathons. They are the single best place to learn computer science.
I'm definitely going to be looking at some hackathons now for sure. So my next question is, would you recommend pursuing higher education, such as a master's, for a greater advantage in entering the software industry? Or do you think experience is more prized in the software field?
So this is a two-layered question. One, it really depends on what you decide to pursue. For a lot of more of these specialized fields like machine learning, you do need a master's and PhD to kind of get that first step in the door. For a lot of core software engineering jobs, less about experience, really depends on your skill set. So how comfortable are you with the tech? How good can you actually program? And how much, I like to say less about years of experience, more breadth and depth of your experience, right? So have you gone to hackathons? Have you built projects? How applicable are they? So if you're doing just traditional software engineering, no, you don't really need a master's or PhD. But if you are going to something more research intensive, like machine learning field, or you're doing some really cool work with robotics, probably need a master's or engineering degree, PhD degree, sorry.
Interesting. That's great to know. So what are your thoughts on how the tech industry is evolving? And do you think everything will be automated in the future in, say, 20 to 30 years?
So I'm going to answer your second question before I answer your first one. So no, I do not think everything is going to be automated in 20 to 30 years. I think what we watch on TV can be kind of misleading on, yeah, we're all going to get our jobs automated away. It's not the case, right? Humans are always going to be needed. Humans are always going to be involved. But the jobs we have today are going to change, right? So on how the tech industry is evolving, I'll tell you, if you were to ask my dad or my mom 20 years ago what a solutions architect at a cloud company does, they would have no idea what that is, right? My job did not exist 20 years ago. So think about it that way, that in 20 years from now, there's going to be new jobs that we don't even know exist, right? Think of quantum computing, or think about how artificial intelligence is going to change, right? The jobs that are going to exist now won't probably exist in 20 years, and vice versa, right? We don't even know what's coming up, but it's changing every day. I think pay attention to the news, look at these emerging technologies that people are talking about but haven't been really implemented too far. Think quantum computing, think blockchain. I think those are the ones that are going to be really big in the future, but things aren't going to get automated.
Yeah, that's a really good point. We don't know what kind of jobs we're going to see in the future, but staying updated on what's going on is definitely a good way to get ready.
Exactly. I didn't know my job was a thing when I was in grade 12. I wanted to do something completely different. So you guys are young, right? Use your time in university to figure out what career options actually exist. Don't pigeonhole yourself into a specific job or a career you want. There's a lot of.
For sure, yeah. Making sure not to pigeonhole ourselves and really exploring our options, which is something personally I'm really excited to do because I'm going to be doing co-op in my post-secondary and I hope to explore a multitude of different fields. So, yeah. So as a Western grad, what do you think helped you get to the post-secondary option you wanted in high school?
Yeah, so just so I understand it correctly, why I chose the undergrad I did and how did I make that decision in high school?
How you made the decision and what kind of steps you took to get to where you are, to get to that university program.
Yeah, for sure. So one, to be honest with you, like many undergrads or many high school students right now, I had no idea what I wanted to do with my life when I was in grade 12. So I literally Googled highest paying undergrad degrees and computer science, actuarial science, and math came up, right? So, and they're fairly flexible degrees. Like I had friends in my graduating class that are now working in banking. I have a few that are working in the medical field. I have a lot of them that came into tech with me. And it's a very, I like to say, broad degree, right? You can do a lot with it. So if you're like me and have no idea what you want to do, I'd say these are great professions to pursue and great undergrad majors to choose. How you can prepare yourself, if you're fond of math, take your 3 maths, right? Your data, your functions, your calculus. Take physics, chemistry, especially, and if you can, and I'm not sure if your school has the computer science program, but make sure you take your computer science classes. They can be very helpful.
Yeah, BR actually has a computer science program, and I took it in grade 11, and I really enjoyed it. It actually sparked my passion for coding, and I'm going to take computer science next quadrimester, and we have AP computer science as well. So for sure, yeah, the programs at BR, taking those courses, data management, I'm actually taking that right now, and it's a really great course. So for sure, yeah, taking those courses is great. And I like how you mentioned how even though you did like a math degree, and a lot of your friends did, they went into all these different fields. And it really goes to show that you're never really boxed into one thing. You can always branch out. So that's really great to hear. So our last question is that you mentioned in your bio that you specialize in machine learning with a primary focus in natural language processing and computer vision. So any words of wisdom for students that are interested in pursuing machine learning?
Yes. So number one, understand that a lot of stuff you hear about machine learning can be overblown about the impacts and how like cool it is and how it can solve every problem. It is a lot. I like to say it's really easy to get into, but then it becomes extremely hard to learn after that initial kind of step. So don't feel discouraged when you start learning it or decide to pursue it. That, oh my God, I don't know any of this stuff. Because there's a lot to learn, right? People dedicate their entire lives to this stuff, so it takes a lot of time to learn. Play around with some of these open source projects like TensorFlow, PyTorch, Google, Amazon, Microsoft. They have these amazing resources completely free to check out. So highly recommend just Google, machine learning on Google, machine learning on Amazon, machine learning on Microsoft. And they have some amazing tools for you to pursue. And yeah, just look at kind of what's been done today and look at how you can apply some of these problems they've already solved to your day-to-day, right? What helped me really learn was I learned object detection using an open source TensorFlow project, right? I think, in my 3rd year of undergrad, right? And it was because I wanted to build something that detected ovarian cancer. So that was kind of, hey, think of a problem you want to solve, then work backwards from that. That will really help, especially if you want to learn machine learning. Because when you get into the weeds of things, it's all math. it can get very discouraging when you don't know the math. So think more broad before you go too deep.
Yeah, it's some really great advice. I'm going to take that myself. Actually, just to kind of like a shameless plug, but the STEM team has actually developed an activity on our brand new website where you get to explore Google's Teachable Machine app, where you get to use like computer vision models. For example, we detected whether someone was wearing a mask or not in images. So definitely check out that activity to get started with machine learning. And even if you are familiar with it, it's still something great to try out. So shameless plug there for our STEM team website.
I'll check it out. You have to send me the URL.
For sure, I'll make sure to send you the link. So I think that wraps up everything that we have for you today, Raj. Thank you so much for your time. We really appreciate it. And you have some really great insight for our audience.
Oh, thanks a lot, guys. Have a great day.
You
Thank you so much.
Thank you.
Hello, I'm Tam, and I'll be the host for the Bishop Reading STEM Team's interview with Brynn King. Brynn is a hardware developer with a specialization in radio frequency design. So we're super excited to have you here, Brynn, and we'll just get started. So, our first question was, what do you like about working as a hardware developer?
I think my favorite thing about working as a hardware developer is that I'm always learning. There's always new technology out there, and I'm never bored. It's always a continuous design, new things to add to the design, and it's never a boring day. Always a problem to solve. So.
All right, that sounds so interesting. Yeah. So what does a typical day look like for you?
I guess it depends. First of all, what a hardware developer does is we're designing and building electronics. So it could be consumer electronics like you would use every day. It could be computers that you would use, or computers, maybe like bigger infrastructure computers. So it really depends on the design cycle. There's like in the beginning, you might be meeting a lot with mechanical engineers or other types of designers to kind of figure out the product that you're going to build. And so there'd be a lot of meetings and planning and stuff around that. And then once you get into the design, it's a lot of doing schematics and printed circuit board layout on the computer. And then finally, you might get a couple of revisions of your hardware back, and then you'd be in the lab bringing it up, which means like getting it to work. It doesn't always work the first time, and there would be revisions in the design process after that, until finally you have a product that you can sell.
Wow, that sounds like a really detailed process. It's so interesting that there's so much kind of like new ideas that have to go into like what you do every day.
Yeah, we're trying to always put the newest technology that we can into our products and hope that it works.
All right. So we were also wondering, what was your experience in the co-op program at Waterloo? And would you say that this sort of experience helped you in your pathway?
Yeah, 100%. Like the Waterloo Co-op experience was awesome. It's a lot more work because every 4 months you're applying for jobs and interviewing for jobs. Like it seems to land exactly during exam time. But it's worth it for sure. The first couple of jobs that you have maybe aren't exactly what you want to do in the long run, but you kind of get a feel for what it's like to work in a company and the kind of work that you would do, what you like, what you don't like, and then from there you can kind of figure out your path and get into more jobs that you would like. And then once you have kind of the confidence to do the interviews and know how to get a job with a company, it makes it so much easier after you graduate. And you have a resume full of experience. And sometimes, well, a lot of times on your last co-op term, you might decide that that's the company you want to work for full time afterwards. So yeah, it's amazing. It's a great experience.
Thanks for sharing those insights. And just kind of building off of this question about the University of Waterloo, is there anything else that sort of sets Waterloo apart from other universities with the same program?
So yeah, definitely the co-op is number one. I'd say, yeah, Waterloo's a bit of a tough one. There's a lot of pressure to because every 4 months you're trying to find a job. So it's a bit of pressure to balance work, your schoolwork and getting the job that you want. And if you're on a bunch of teams or something like that, I didn't join too many of the teams available, but there's a lot of good teams, whether it be the robotics team or something like that. So they have a lot of new equipment and yeah, it's a good school overall, but I'd say what sets it apart by far is the co-op program.
Yeah. So we were also wondering, how long have you been interested in engineering, and when did you decide that it was the right profession for you?
Yeah, it's a bit of you never really know. You don't know what you're getting yourself into. It's a bit of a guesswork. My dad was an engineer, so I was familiar with what engineers did. He's a civil engineer, so it's a little different. I always really enjoyed physics and math in school, so I knew definitely needed to get into that. I could have gone straight into math or physics, but engineering is kind of applying math and physics and building things. So it's a bit more hands-on and taking the science and the math and actually designing something. So that's what I liked about it. Yeah, and then electrical engineering specifically, it seemed to have the most amount of physics and math. And it's also interesting to me because there's a bunch of different options. So you can go into electrical engineering and do a million different things within electrical engineering. So you're sure to find a path, or a lot of the people in my class, they didn't even do engineering after. Some went to medical school or became managers, salespeople, investment bankers. It's just a good base degree to have. So, and I'd say the same goes for any engineering degree is a good base degree, a math degree, computer science. They're all just really good degrees to have. And then from there, you can do what you want, whether that be engineering or you can do a graduate program in something completely different.
And thank you so much for sharing that insight. I think it's great that we can still keep our doors open even after undergraduate studies.
Yeah, a lot of people decide in first year that maybe what they chose isn't exactly what they wanted. And I just felt like electrical engineering, there's a lot of pathways you can go. It opens a lot of doors.
That's awesome. So what do you think helped you get to the post-secondary option that you wanted, from when you were in high school?
From high school, I didn't do anything special, I don't think. I played a lot of sports. So that's about the only, I didn't join any teams or anything. But it was always just school was number one, made sure to get good grades. I wasn't particularly good in certain subjects like English or something, but I knew I had to get a certain grade in that. So I would go and ask my teacher, I need this grade. What can I do to get it? And then I would do the work. And at the end of the day, school was number one for me. So I always had that in my mind.
Thanks for sharing that. So if there's one thing that you could change about your professional journey, what would it be? And would you do anything different?
That's a tough one. I think there's a lot of different routes that I could have taken. Things happen quickly in technology, so it's rare in my sort of technology in profession that you would stick to one job and do that for the rest of your life. So I've been kind of jumping around, and it's cool to see. I first started with some consumer electronics type positions at Apple and BlackBerry, and I really enjoyed those. And I liked the bigger company with all their new equipment. But then after that, I did a consulting thing, and you get experience with a lot of different products, which is interesting. And now I work on products that television reporters would use. So that's completely different again. And it's nice to try the different things. And I'm not sure that I would do anything particularly differently. I just like to try new things and see where it all leads. So
Thank you for that. Last question here is, what advice would you give for future students that are going into the STEM field?
I think it's a really great field to get into. There's so many options. There's so many jobs available in this field. It's exciting. Technology is always changing. You have to kind of make sure to keep up with it. So I would just say get a good base degree. So whether that's engineering, math, computer science, like I said, and then the doors will open from there, and you'll decide what you like. So if you have a bunch of options out of university, then choose what you're passionate about, because there's so many different options. You're sure to find something within the field that will click with you.
Thank you so much. I think that pretty much wraps it up for our interview today. Thank you so much for coming out and joining us. And we hope that you have a great week, and thank you for sharing so much insight with our audience.
Thanks for having me. Have a great day.
We have now reached the end of this event, and we hope that you enjoyed it and learned something new.
If you have enjoyed today's event, please stay tuned for our second career outreach event, which will focus on math and technology fields and will be happening in the coming months.
Make sure to follow us on Twitter at Writing STEM and on Instagram at Bishop Writing STEM to receive updates about upcoming initiatives.